Okay, so I'm giving a very short introduction to this session. So, okay, so I'm starting with the philosophy of safety by design. And in terms of safety management, you have two concepts to deal with safety management. Either you just control the safety management based on received evidence, is what you do in safety by design, or you use the precautionary principle, which takes account that the public just don't want any of this hazard around. There's no scientific basis, so they just ban it. And a very good example is the latest epidemic of COVID. If you apply a precautionary principle to COVID, you impose a nationwide lockdown. On the other hand, if you're going to control the epidemic, you base your control on received evidence, which is applying the test and trace system and leading into vaccination. Okay, so I've always seen safety by design, and I've had this idea for many, many years because it can apply to very many things, including the COVID, including environmental pollution, including climate change, and of course, production of nanomaterial. And I always see it as a control system, in that you have a production line, which is your production of nanomaterial, and at the same time, you screen your nanomaterial, and the results from the screening control the design. So if you get toxic nanomaterial being produced, you automatically moderate your production. So that is how I see safety by design. It can be applied in a reductionist or specific way, or you can use the kind of control system idea at a very high level, as I've already mentioned for COVID-19. So they told me to be very short, and this is the kind of system I'm talking about in nanomaterial production, where you have a production line at top, and then you have an output, and you have a screening line going down to a sensor, and the measured output is moderating your design of nanomaterial. Okay, so safety by design, as I've already said, operates at various levels. I've talked about the highest level. It involves continuous dialogue between providers and regulators. And at the reductionist or low or specific level, it takes many ideas from drug design development, for example, where you're controlling the production of a drug directly by screening it as soon as it's been produced and moderating your production through the screening. And finally, I just put on one slide that obviously I've used this in our SABYDOMA project, which started last April. And here you can see the control system loop in green and also in red, and the production line on top. And the whole point of, I have to say, I'm a technologist, so I think of technology as that we operate through 4 different case studies, and we go from the left of that arrow from the lab to on-site operation using that feedback loop all the time. So I guess that's the end of my talk, and I'm happy to consider any very short questions. We go on to the other projects in our working group E, by the way. Okay, so SbD for nano. Is that you, Carlos? Hello? I can't hear
you already. Please unmute your microphone.
Okay, I'll do that. I'll mute mine.
Carlos, we cannot hear you. You have to unmute your microphone. The red button underneath the face or the... Yes, now we see you again.
Okay, can you hear me now?
Yes, thank you.
Okay, perfect. Hello, good afternoon, everybody. So I'm Carlos Fito. I'm the coordinator of the Safe-by-Design for Nano project, and I will try just to present the project in 3-4 minutes, just following this pitch elevator presentation. Please, the next one. So this Safe-by-Design for Nano, the title, as you can see, is a computing infrastructure for the definition, performance testing, and implementation of Safe-by-Design approaches. So at the end, if you go to the next, please, you can see our main objective. So the main objective of our project, following always the principle of the Safe-by-Design, here is to develop a kind of very advanced tool. We say the tool as the e-infrastructure. So this e-infrastructure will focus on trying to guide the industry in selecting proper Safe-by-Design approaches, considering for one side the toxicology of the products and try to balance between decisions, between the reduction of the toxicology and always maintain the effectiveness of the products. So our main concern here is try to develop a structure that guide the user at the end to reduce the risk in terms of toxicity and exposure, but always maintaining the functionality of the product in the final products, in this case, like paints, cosmetics, or products from the pharmacy world. So our main outcomes here is the infrastructure as such. Then also we have a very challenging here tool is the relationship between the properties and the function of the materials. So which properties determine which functions. So we need to develop a kind of models to develop this one and implement in the project. Then also we are going to develop a new library of risk management measures and also different guidelines to cover all the work of the Safe-by-Design to try to guide the users on selecting proper measures. Then in the next, please. So you can see our consortium. So the main point of our consortium is that we have up to 10 companies. So we are people from the research area, but also we have 10 companies that are in charge of the development of the nanomaterials. So we have different kind of materials. And then we have these companies in validation case studies. So we will try to demonstrate our approach, our tool in these companies. And then also we will have the support of the advisory board. As you can see, we have people from NIOS. We have also people from the Hong Kong University, from the Duke University, and the University of Manchester. So we will try also to demonstrate our tool with this college from international point of view. And in the next, please, you can see more or less our work packages, but at the end we are working in work package 1 to try to make a gap analysis of the different resources for Safe-by-Design. Work package 2, we are going to develop this kind of relationships between properties and functions. In work package 3, we are going to test the materials, the toxicological profiling when you are implementing surface modifiers. Work package 4, we are going to develop new models to predict exposure and to predict the effectiveness of the risk management measures, like, for example, ventilations or different kind of respirators. For package 5, it will be the focus. So we are going to develop this kind of infrastructure, and work package 6 will be the demonstration phase. So that's going to be the more relevant because we need to demonstrate all the activities in the project in the real case studies. And just the final slide is just where we are, the progress so far in the project. We have developed the first Safe-by-Design infrastructure. So we have the first draft that we are testing at the moment. We have a new application for the eNanoMapper database. So all our data will be part of the eNanoMapper database. We are developing to design different templates to support the partners on compiling this kind of complex property from the materials. We have completed with people from TNO and CA the gap analysis concerning what we know about exposure and what we know about risk management measures. And then we have a first survey with the stakeholders to know their opinions about the needs and the challenge and the barriers to implement Safe-by-Design approaches. And of course, as coordinator, you are invited to go to the website and then follow us in the different Twitter and LinkedIn. And if you want to know more, you can contact me in my email address. So thank you for attention.
Thank you, Carlos. We have the next project, Soco, to introduce quickly. Thank you very much. Soco, you need to unmute your microphone underneath the NanoSafe ball. We cannot hear you, Soco. Now we can.
Hello.
Yes.
Sorry, I didn't see the. So, good afternoon, everybody. So I'm Soco Vazquez Campos from Leitat Technological Center in Barcelona, Spain, and I'm here to present. I'm one of the scientific coordinators of one of the NMBP 15 projects, SABYNA, and the aim of the project is to provide simple, robust, and cost-effective approaches to guide the industry in the development of safer nanomaterials and nano-enabled products. Then here I will give you a context of what we are trying. I think in all of the NMBP 15 projects, we are trying to help industry to go to implement the safety considerations at the early stages of their innovation process. So here is a small representation of how this stage to gate, the Cooper stage to gate framework, the different steps from the idea to the launch of the product into the market. And as you all know, safety considerations should be always implemented from the beginning and from early, but it's not always the case from all the industrial partners or industry from all the sectors. And when we are talking about the Safe-by-Design concept, we are actually here in the early stage of the, let me use the pointer. So I don't know if you see my pointer. So here in the early stage of the innovation process is where the Safe-by-Design concept will be aiming to be implemented for a product, a nanotechnology-based product in the development process. And of course, from the beginning, always considering the whole life cycle of this nanotechnology-based product or the nanomaterial that the company is working with. So always trying to introduce in their innovation. And of course, we have to not only consider safety of the product, but also safety of the processes involved in all the development stages of this product and the processes that are taking place afterwards when the product is in the market. And these safety considerations are always related to the impacts that these new additives or the nanotechnology-based additives will have in the domains of workers, consumers, and environment through the whole life cycle of the product. Then what is SABYNA? SABYNA's approach here? I show you schematically the the approach that we have for helping the industry in this process of implementation of the Safe-by-Design concept. So what we have is a lot of efforts done in previous projects and previous initiatives, and many organizations working on developing models, tools, methods, generating databases, as we seen this morning, all the efforts that we have on the different domains for collecting all the data generated. But all these existing resources, as you know, we know also from stakeholder consultations in previous projects that still there is a need for the industry to guide them how to use all this and how to streamline all these existing resources for them to be useful, and to make them user-friendly, and to guide the industry in the process of identifying the risks, and also to provide some cost-effective Safe-by-Design solutions, as I said, towards safer products, but also towards safer processes, and all that to guide and streamline and make these workflows, identify the workflows for the industry. We will put this into a web-based guidance platform, so the SABYNA platform, and then we will showcase the use of this SABYNA platform in two sectors, in paints and 3D printing. So we are working closely with industry from these two sectors, and collecting as much as possible all the information, data, and resources they are using to tailor our platform into these sectors, and have the specific and the proof of concept of our platform in those two sectors. So I think that's all. My last slide was just to guide you to our actually webpage for more information and my contact details. So thank you very much.
This is, of course, very interesting to us, but it's very, very low amount of time which we have for introducing the projects. I would like to ask Anna to shortly introduce ASINA project, and then we do case studies to apply all that. Thank you. We can hear you, Anna. Please.
Okay, thank you, Martin. Can you? Okay, yes, perfect. So I can start. Good afternoon. Okay, thank you. Good afternoon, everybody. It's a great pleasure for me introducing ASINA project, the last of the NMP 15 project. To turn the next slide, this one, no, okay. They are not in the, well, in any case, sorry. Okay, so the ASINA project, as the other projects under NMP 15, aims to implement in an industrial framework what is the Safe-by-Design concept. So in order to enhance the capability and market acceptance of the proposed Safe-by-Design strategy, we will move in the project through the steps suggested by a well-structured industrial management methodology that belongs to the Six Sigma practice. This is called DMAIC from the initial letter of the single step, and as schematized here, you can see that we start with the definition, so making hypotheses on products and processes consistent with customer demands and the enterprise strategy. Then we apply our testing strategy to measure the quality and mainly the safety of the products and of course of the process of integration of nanomaterial in the products. Then there is a fundamental step of analysis. We heard this morning a lot of interesting progress in nanosafety cluster for data management, curation, and the extraction of the main information. So this step will generate the response functions that we look for in order to correlate the parameters of the materials, the variables of the materials and of the process to the performance attributes in terms of safety and of course of functionalities. Then of course there is the design and redesign step. We have test beds available to develop and optimize our design solution, our design strategies, and finally a verification steps. That means a scale up of our strategy into pilot plans to implement and validate the best design solution. So here is what I mentioned, the main important step of analysis that in ASINA we call it the expert systems. That means to link the characterizing factors of material and process to the techno-economic, other exposure and life cycle assessment impacts attributes in order to facilitate the decision step that will make a rank of SABYDOMA strategy and that provides suggestion to the innovators but also regulators on the efficacy of such SABYDOMA strategy. The main product value chains we deal with in ASINA are two. One is the antimicrobial, antibiofilm, the pollutant coatings developed in clean technology, in particular antibacterial textile and photocatalytic filter. And then we will address value chain in cosmetics for the development of such nanostructure capsules delivering active phases for anti-aging functionalities, but also for antibacterial hand cream. So I'm sorry, but just a second. Okay. Considering the case studies that we will develop in ASINA that mainly deal with antimicrobial solution, we are happy to inform that ASINA has been considered as a project and included in the list of Horizon 2020 projects whose result can have a relevance towards the fight against coronavirus. And I will better explain later in the short presentation about case study on the antimicrobial nanotechnology products. So that's all from my side. I'm sorry, but I had a different, the final remarks if I have time, but I had a different order of the slides, but in any case, I finished. Well, I see that I am the next speaker as well, is right?
This is great. We have an overview of the 4 projects, and now we really
can you hear me?
On 2 application examples how this could be running, and then we would also like to get some feedback from the audience. So Anna, please be so kind and present us the case study number 1 on this antimicrobial solution, which is also going into the direction of anti-COVID activity, which you just mentioned. Thanks a lot.
Yes, so I can continue. Continue the discussion. Yes, of course, SABYDOMA project will address more general concepts and all the issues and all the items you heard before. So it's more general approach, but into details of antimicrobial solution that are one of our main case study, we can make some general consideration. The battle against microbes from a nanotechnology point of view has been addressed by many different points of view, many different perspectives. Here are some of them. The photocatalytic oxidation, so exploited in nanophotoCatalysts, is an advanced oxidation process that is very useful and proposed for the removal of trace of contaminants and microbial pathogens. But also the nanostructure absorbents, so I mean nanomaterials, but especially hybrid composite structures that are powerful sorbents that can be used for air, water cleaning, and for improving performance of the most and give better performance of the most common activated carbon. But in general, the filter membrane technology and the nano-activated filter membranes offers even great opportunity. They can improve membrane water permeability, biofouling resistance, selectivity, mechanical and thermal stabilities, and incorporate all the other functions in one unique multifunctional solution. But also in a field that is not mine, but nanobiosensors are very, very important tools against the battle against microorganisms. So I'm sorry, I didn't change the slide, but it changed. Okay, so going back to the second slide, yes. So what I would like to focus is on nanosilver technology. That is one of these solutions, but specifically in the direction to deactivate virus with a specific reactivity. So we know silver nanotechnology is an ancient technology. The colloidal silver is known since ancient times, really, and has demonstrated antimicrobial activity. So it is used as disinfectants for technological application, coatings, but also in nanomedicine. So which are the information that we can add in order to validate such technology, especially from a Safe-by-Design point of view? Well, first of all, the knowledge of mechanism. We know from literature, and it almost recognizes that silver act is action, silver nanoparticle act is action through the release of ions, but also with a nanoscale reactivity. And here I represented two different most likely mechanisms in case of bacterial and in case of virus. In this case, SARS-CoV virus, whose dimension are more close to the dimension of nanosilver. So in the case of bacterial, the most recognized mechanism is the release of ions and the interaction of ions with the membrane receptors of bacterial that can complex tile groups and determine elysis of membrane, but also induce some oxidative stress mechanism. In the case of virus, we are in another scale of size. So what is reported so far in terms of nanosilver reactivity is that silver can surround the virus receptor domains and so block the entry of the virus into cells. In this case, a design solution could be the embedding of virus in a polymeric matrix that can entrap better the virus and so produce the desired effect. So it seems what is important to highlight is that from a point of view of Safe-by-Design approach, this is a typical case where we deal with materials that are intentionally toxic. So what is very, very important. What is our contribute from nanosafety class in this case is when we deal with the use stage that is the more relevant for tracking the reactivity of such material, we need to identify a safe range that is between two reference dose value, one that is related to the antimicrobial activity and the other one that is related to the potential toxicity. So what is very, very important is to jump in this safe but active range. So under this perspective, for sure, we know that nanometals are quite not always alone. They are always surrounded by a coating that is the stabilizing agent, the capping agent. So Safe-by-Design can act here in this coating. This coating can control intrinsic toxicity, can control the interactions, the direct interaction with biological target, can control the bioavailability of silver nanoparticles and ions. But we need also to know that the coating, the presence of coating and the engineering of such coatings that we can do can impact on the life cycle of the synthesis, on the final cost of the products, and also on the process of integration of nanoparticles in the final nano-enabled products. So all these are issues that we need to take into consideration if we want to plan a Safe-by-Design applied to this kind of material. So what is the remaining are questions that we prepare for the audience, but I don't know, Martin, how you can manage them. Okay, in this way. So the first question is, yes, I made just a short introduction of the main issues related to the Safe-by-Design applied of this specific technology against microorganism from nanosilver. But I was curious to know which can be the from the audience the awareness of Safe-by-Design solution applied in a nano-enabled manufacturing process. So what can be the priority in terms, if you want to follow to a Safe-by-Design approach? Maybe the product performance, regulatory restriction. In case of silver, these are very, very relevant. I can say you, because we are trying to develop such product with a big manufacturing company. But also, of course, we know the work and consumers and the environmental safety, the cost, the product sustainability, overall product sustainability. This was the first question. And then I have another one. Yes, I don't know, Martin, if there is another list of questions. Hello, can you hear me?
We got 3 questions and people are already filling the poll.
Okay.
You can also
perfect.
navigate through the survey by scrolling on your screen.
Okay, sorry.
At the moment, we have 10% of attendees completed the survey.
Okay, thank you. Sorry, I didn't know.
And I will put them on this display when more people have completed the survey.
Okay, perfect.
But maybe meanwhile you can talk to the second and third question. We still give it a little bit more time to make it a bit more representative. It's nicely moving on.
Yeah, I know. I didn't know how much time I had left, so for this reason I tried to run. But yes, the first question was more general for for the perspective of a nano manufacturer. In this case, is more from the perspective of a nano innovator, a material scientist that want to design a product that is active against, in this case, microbes. And so which kind of advantages can take from SABYDESIGN to improve the range of applicability, to know how to control and reduce workers' exposure, obtain solution to improve waste management process, and I refer here to the circular economy that can be easily applied to such persistent nanobiomaterials that can be recovered in many products where they are integrated to, or of course all the above solution.
So I would say we have now 27% of people have completed the poll. I would say that we end the voting and share the results. And have a quick look into, and you may want to comment on it.
Yes, and to have a look where I have to go. Okay. So what would be the priority for implementing SABYDESIGN from manufacture, product performance, regulatory restriction, and the main seems the worker and the consumer environmental safety. I'm happy to hear it because from my point of view, this is the less not the less important, but the more easy to overcome the worker consumer safety, because especially in the case of silver nanotechnology that are a technology processed at liquid state, I don't think that there are many concerns about worker safety. But I'm happy to hear it. And which are the main advantages for a producer, for a designer of nano additives? Yes, all the above solution, of course, I selected for this reason. And yes, improve the range of applicability, of course, is very important because the range I highlighted before. Toxic, but not toxic for human and the environment. And finally, the third question would be the potential SABYDESIGN needs for a nano-enabled product manufacture, a list of additives, co-formulants, yes, that can be optimize the product, obtain solution how to improve the manufacturing process to reduce worker, again, solution to improve waste management, yes, and now restriction. Okay, so seems from a general analysis seems that the regulatory restriction and requirements are not so important. Actually, I'm so to say that, especially for this kind of applications, the regulatory requirements are very, very strict and very, very relevant on the final application because they fall into not only to the general regulation of chemicals that is well-known REACH, but also to the biocide regulation is very, very strict, and in some cases not so in line with the REACH regulation. So this is, from my perspective, one of the main problems now, and how to match safety with regulatory requirements, again, is very, very challenging issue. Okay. That's it for my side. I don't know if I have to do something else.
Thank you very much. And this was already quite interesting. We are looking into another case study presented by Soco. And I just upload it now. I guess we can start. Thank you. We have again problems hearing you, Soco.
Can you hear me?
Yes, we can hear you.
Okay. Okay. I said that the second case study we would like to present here is nanotechnology-based polymeric parts for produced by 3D printing. And why I cannot? Oh, yes, I can advance the slides now. Okay. I skipped the first slide because I already presented. So which case study I wanted to introduce to everybody to then go into discussion into it. So the case study described here is an anti-static parts that are produced by 3D printing processes. The nano-enabled product I put here an example can be an adjustable fastener. Then is the nanomaterial is a polymer nanocomposite, and the nanoform is a carbon-based nanomaterial. And of course, we have the matrix, which is the polymer. So I wanted to show here all the life cycle stages of this nano-enabled or nanotechnology-based product from the production, manufacturing of the nanocomposites, the printing of the final product, the use of the service life of this product when it's into the market, and also the end-of-life processes, including recycling. So you see all the scenarios, activities along this product life cycle, and all the considerations that we have to have in terms of safety. So in here, if we go even further and link this case study with actually the end of life of these materials being disposed into so the waste coming from these the different processes in this life cycle of this nanotechnology-based products, then we can link this to the problematic that we've been talking, and the link from the our nano safety community into the microplastics problematic. So here we can see that we have this coming as a how to get this zero pollution objective of the Green Deal. So 300 million tons of plastic manufactured each year, plastic taking 95 years on average to degrade. They accumulate in the oceans eventually, and all the life cycle of this plastic, so from disposal to the ocean. So we have to trace them all the way, and all the processes that can lead to this these wastes and this degradation of these polymers into the microplastics. So all together brings a really complex case that is quite real life case study. So having this in mind, I invite you to go through the question in the survey. So if Martin, you can put the survey on. The questions are really in the same line as we had before. So again, we are interested in knowing your opinion about the priorities for implementing Safe-by-Design solutions when you are a nano-enabled product manufacturer. So here you have some options. And the second question is, what are the main needs? And in this case, as a nano additive producer, when implementing Safe-by-Design solutions. And again, you have several options that you can choose. And then the third question is, well, we have third question, a fourth question as well. The third question is, which are the main needs from the nano-enabled product manufacturer can have when implementing the Safe-by-Design solutions. And then a question about the microplastics and how to solve the problem of plastics in the environment. And we have several options for you to choose, and also open discussions to, we would like to have open discussion on this and these areas from the 2 case studies and from how you see the needs from the different perspectives, and also the link with other areas such as the microplastics and the problems with the waste coming from all the life cycle stages of a nano-enabled product. I don't know how is the survey going in terms of participation.
Like to leave it on for a bit.
Should we wait a bit more to show the results?
And people have completed the survey. So it will take maybe just a few more minutes that more people have completed the survey.
Yeah.
We are now at 24% people completed. Earlier, I guess it was somewhere in the area of 28, 30%. Now it was above 30%. Give it a few more minutes.
Yeah. And yes, then we will use, I think the chat is the main way of communication. So to put your comments, your thoughts, maybe in line with the questions or not in line with the questions, so we could start having more the opinion from your side. So we want to have the opinion from the participants, and we don't want to present anymore. So I think we show you briefly what we are doing and we are trying to do in this project just starting.
So we have now reached 33% completion of the survey. I would end voting and display the results.
Yeah, sure.
You can comment on that.
Yeah. Okay. Again, here the main the answers they are dominated by the workers, consumers, environmental safety. So what will be the priorities? So again, the same as in the case study, in the previous case study. So this goes in the same direction, which are from the nano additive producer point of view. And here we have, again, all the above needs will be of interest for a nano additive producer. So to obtain solutions on how to improve the synthetic process, to reduce worker exposure, waste management, and to produce nano additives with reduced toxicity. So I think this is the main issue. Also, following as well, the obtained solutions to produce nano additives could reduce toxicity, which is, I think, one of the main priorities for the producers as well. In the third question of which are the main needs that a manufacturer can have implementing Safe-by-Design solutions, and here what we get is also, again, all the above needs is the dominant answer. And one of the options also that most of you answer is a list of nano additives which allow to maintain the desired performance in the final product. As I said, here it's also one of the main drivers of all our projects is that to that performance of the product should be maintained on all our solutions that we give to the industry to implement the Safe-by-Design solutions. We always want to keep the performance of the product. Again, here, in terms of how to solve the problem of plastics in the environment, I think here we have the three last answers are almost equally. So modify plastic manufacture to render it biodegradable, to make it more biodegradable, and try different disposal options. So recycling, composting, incineration. Perform LCA and break the cycle at some point. So these, I think, a few answers go to the ban all plastics production. So, okay, I think now people from so Andrew can and also Anna and Carlos, I think they can join me in the discussion if we can open the questions. So we have here, biodegradable plastics did not work too well. Where will it work for nanoplastics? Andrew, do you want to say something?
Yeah. I just want to say I found your talk absolutely fascinating, and I also found Anna Costa's talk on the nano somewhat, sorry, fascinating. The plastic thing and the recycling thing. Well, first of all, I want to say that, you know, I really looked hard at your questions, and I did this before the meeting as well, and I felt I just couldn't decide if I could rank them because they were all equally important. You know, it shows very clearly how, I think that illustrates to me how clear safety by design, you're effectively talking about control or a balance. I mean, you're always wanting for economic reasons to maximize your productivity, efficiency, but you're also going to be wanting to maximize your sustainability, and also you have to abide by very stringent regulations. So I think everything you asked me there are equally important. I'm sure other people disagree with me. The other thing, I think not enough work is done on, first of all, I think the idea of plastics, I'm sorry if I'm talking too much, but the idea of plastics is absolutely very obvious, because you said that 300 million tons of plastics are produced each year, and it takes 95 years for the plastic to degrade. So they're going to accumulate in the environment, and because the way the environment works, they're all going to end up in the sea. So I think to anyone in the public, it's just plain obvious that they're going to accumulate. But I don't think enough work has been done on their degradation. I mean, a lot of work is done on recycling of wood and composting of wood. I do it myself, actually, because I have a small holding. But with plastic, it's also possible to form some kind of artificial soil or recycle it or accelerate its oxidation and so forth. I don't know if anyone else has any comments on that.
Yeah, there is a comment. So Effie says that that the most easy solution for plastics to reduce their use, but it will take time to implement this. And I agree with Effie. I think this is one of the, to me, one of the solutions is to reduce, but it's always a difficult thing to implement, to teach society how to follow the rules of reducing the use of plastics. And there is another With the drive to circular economy, wouldn't we want to extend the life cycle? That's the question from Neil. Anyone? Yeah.
Yeah, they made very resistant plastics, haven't they? I mean, Teflon is a very resistant plastic, and it's supposed to last forever. Although I know it does degrade, having used it in the laboratory for many years. But they have made very resistant plastics, and in fact, these are the worst because they are eventually disposed of, and they really do persist in the environment. I mean, some plastics actually do degrade, and I have carried out my own experience in my small holding, looking at the degradation of plastics, and they do go eventually. It takes several years, but they do go very slowly. And you can accelerate by cutting them up. So I think the other point that I find so interesting was the fact someone said you should ban plastics altogether, but this is an example of the precautionary principle where you just ban them because they're perceived to be a hazard. And perhaps that's the right thing to do. I mean, we've done that with some things. We've done that with lead additives to petrol. We just ban it. We don't argue about it. Or with sewage sludge dumping in the sea, we ban it. We don't argue about it. But perhaps plastics has a need somewhere. Yeah, sorry to dominate the conversation. It's a very interesting.
Yeah, I think it dominates this subject as it was the last one. I don't know if somebody wants to go back to discuss about COVID case study or the possibilities of the Safe-by-Design implementation in other in the areas of industry. So here, going into the comments, there is a need to make recycling of plastics more cost effective on a larger scale. And yeah, this is things that are going on and things that are suggested in terms of recycling, in terms of keep working on the biodegradable plastics. And yeah, here again, the biodegradable plastic is nice, but looking at suitable, less persistent options is a bit missing, it seems. Yeah, from Eric. Yeah, I think this is the point that I think is a lot of work to do still in these areas of recyclability and more options for biodegradable plastics. So I think still we are missing some work in these areas. And Neil, again, do you think socioeconomic analysis techniques will help where there is a need to balance positive and negative impacts? Yeah. Yes,
sorry,
go,
I
Andrew.
think that's one of the best things that's come up. I think that describes looking at safety by design at the highest level. It's a philosophical concept, and it's a question of management. And I think socioeconomic analysis, looking at positive and negative and balancing the two, I think that's brilliant. Thank you. Yeah, put that down.
Anna, you want to comment anything about you want to go back to any of the comments on the COVID case study, or?
Yeah, but
here you have
yes,
one.
There was a comment by Massimo Perucca that is involved in ASINA project as well. Yes, that highlighted how all the criteria we consider today and also in our nanosafety cluster research related to performance attributes. I not mean only safety, but also the other criteria we mentioned, so cost, life cycle assessment. All these should be considered in a more overall sustainable by design perspective. So again, a multi-criteria analysis is the only one that would allow to balance between all these requirements, all these needs, all these important features. So yes, I think that the final consideration is that we and this is what we would like to do in all our SABYDOMA project. And what I missed to say is that we want to thank you to the coordination of Andrew. We want to collaborate each other to provide a clear indication for the decision step that is the final goal of our project, to provide decision tools for actually choose between one design option and another, and to validate such Safe-by-Design strategy.
Thank you very much, Anna, for your kind words. I have to say the whole summer and spring has been a load of fun, because we haven't just discussed this here, we've been discussing it at our very lively meetings. Thank you, Anna.
Thank you.
And I agree, a multi-criteria decision modeling, and it kind of, I'm sorry about my voice, it kind of emerges as something new that can be put forward into Horizon Europe. This kind of decision modeling at an economic, socio-economic, philosophical high level is needed to, as part of a, and I hate to say it, a very elaborate control system. And the decision modeling is based on all the scientific evidence. So it's basically working with evidence-based decisions. So that's really nice. We've actually got somewhere today. Thank you very much. I don't know what anyone else thinks. I've done a lot of talking. But Anna, I loved your presentation about the nano silver. I really liked it. We have worked on it ourselves, and I loved how it surrounds the virus, because we know it's the soluble silver that kills the microbacteria, but how it works on the virus is fascinating. Okay, anyone else want to say anything?
So thank you so much to all the audience for this quite intense and long day. Thanks for all the presenters of this working group E in the last session number 6. Final word from Andrew and from all the other presenters eventually. So are we fit for translation into sustainable development as demanded by Sören today in the lunch break, or in our lunch, working lunch? The Green Deal concept?
I think we're very much going forward to a sustainable development. I think what's so nice about the 4 projects so far, and including, I must include also the Nano FabNet, which is another project from Steffi, but one of the most interesting things about it are how different they are, yet they all have a common objective. And I've noticed this right from the beginning. And we all put sustainability at the heart of the project, as well as obtaining a good, as well as the economics. I think what came out of it today was it kind of goes back to my introduction, that safety by design acts at all levels, but in fact at every level you're relying on evidence-based decisions, whether it's at the level closest to the actual work, designing nanosilver to kill viruses, or whether it's the highest possible level where you're looking at a global strategy. So I feel that we've really, really achieved something today, and we really understand much more what safety by design is about. Even though these projects are very different, they're all working towards a common objective. And I know that in our next meeting, we're going to formulate exactly what that objective is. So does that sort of sum up the afternoon? I don't know, but I made a lot of notes here. But it's just operating at so many different levels. I was very interested in two of the projects that are applying quite different approaches. One approach, the SbD for Nano, is using a computer approach to industry, and SABYNA, a computer and practical approach to industry. I noticed that whereas in SABYDOMA, we're actually working our technologies through companies, we're actually going to be working with the companies, doing our work in the company's site. So it's kind of slightly different, but we're all working to that common goal. And that's what I liked about today. Okay.
Thank you so much, Andrew. This was a perfect final word. We have seen a lot today. Please, yes.
Yeah, can I just say, I wanted to say thank you, and I want to invite also people to join this working group. We, as Andrew said, we just start, and it's quite open to members and to participants to enter in our discussion. We are leading this from the NMBP 15 projects, but everybody that is working in related projects can also join the working group activities, and please join, and we could keep the discussion alive. And also, as we say, we will keep this multi-criteria decision discussion as one of the main activities for aligning between the main objective of the 4 projects, and that will be needed the expert expert experience here to join us in these discussions. So thank you, Andrew, for leading such a team here, and we're working really well together. So thank you very much.
I'd be nothing without the support of my friends, and I call you a friend.
Yeah.
I've known you for so long, Soco. It's lovely.
Okay, thank you also, Soco, for these final words. This action item up there, which I did also highlight with this little arrow, leads to the subscription, of course, to all of the different working groups of the Nano Safety Cluster.
Yeah, exactly.
Please, people, let us all work on data fairness to make everything available which we are studying at the moment and which we have studied in the past to serve the needs of governance, the needs of safe by design concepts. We need to really kind of preserve what we have gained, what we have achieved so far. Therefore, stay tuned with us, and we are going to hopefully carry this further into a not very easy, very, very challenging, actually, future. I don't consider this to be an easy task, so we really need to work everybody all together and take this with all the computational capabilities that we have at the moment, and that are developing in future into concepts that can be really applied by the people, by industry, but also, as we had very, very provocative view from Martin Mullins for societal stakeholders. Thanks for everybody for participating. And with this, the educational day is over. Have fun at the NanoSafe Digital Conference tomorrow and the days after. And we hope that we can see some of you guys, or maybe many of you guys, next week on the training day, when we have less topics and, of course, can in much more detail and in depth look into some of the tools. Thanks for your attention. And we will in a bit start with the steering group of the Nano Safety Cluster meeting.